In this video we'll talk about debouncing buttons and switches. Up until now we've assumed that when we press a button the voltage will immediately go from a high to a low and just stay there. Unfortunately this isn't quite true. Switches and buttons are essentially two pieces of metal or some conductive material which when pressed together often bounce up and down a couple of times before finally settling. Sometimes they might not bounce at all, and sometimes they might bounce 5 or even 6 times. It's hard to predict how many times it will bounce, and it's a big problem if we're concerned about how many times our button's been pressed, rather than just if it's actually pressed or not. Here's a waveform showing some bouncing for one of the switches that we use in the lab. You can see it bounces up and down 3 times over 200 microseconds before it finally settles. So how do we handle this? Well, we have 2 pieces of good news. Firstly, we don't always need to worry about it. If we don't care about how many times a button's been pressed, just if it's actually pressed or not, we don't need to perform debouncing at all. And secondly, Arduinos have a nice little function called bounce, which takes care of all the debouncing for us. If you go on to study more advanced microcontroller subjects, you'll learn how to do debouncing from scratch and look at different ways to actually write a function like this. But for now, let's just use the bounce function. Well, let's see how this debouncing works. Firstly, we need to include the library that we're going to use. Now, unfortunately, this library doesn't come in the standard Arduino software download. It's a library that we need to add. So if you are using this at home rather than at uni where the bounce library is included, you'll need to unzip the library that's downloadable from the LMS page into the Arduino libraries directory, and so we have our bounce library there. So now that we've included our bounce library, we need to have a button that we're actually going to be debouncing. So let's declare that, and our button will be on pin 5. Next we need to connect our button to our debounce library. So the way we do it is we say bounce debounce 1, so we just create an object that we're going to be referring to this button by, and we use the function bounce switch input. So we're saying which particular pin that we're going to be performing debouncing on, and then we need to specify the debounce period, or how long that we want to perform this debounce for. Now, the example that we had before was quite short. All the bouncing was over within a few hundred microseconds, but just to be safe, let's put in 5 milliseconds. So we've got 5 milliseconds there. Okay, now we need to set everything else up and do something with it. So as normal, we need to set our pin mode as an input for our particular pin. And let's also connect an LED up to this so that we can toggle that LED each time a button's been pressed. So we'll declare the LED up here as well. The LED will be on pin 6. So now that we're all set up, we can actually use our debounce and do something with it. Well, whenever we want to read a switch and have it debounced, we first need to use the debounce update function. So we say debounce1.update. This updates the state of all the variables that are monitoring the switch input. Now we can check whether the button's been pressed. And so the way we do it is we say if high is equal to debounce1.falling edge, we know the button's been pressed. Now I should explain this for a moment. We have 2 commands, debounce1.falling edge and debounce1.rising edge. And this basically allows us to debounce either a falling edge when the voltage goes from high to a low, or a rising edge when the voltage goes from a low to a high. Now when we press the switch, it goes from a high to a low, so we'll be using falling edge. Now this function returns a 1 when the button has been pressed and been successfully debounced. That's why we're comparing it against high or 1, rather than against low, as when we're just checking the actual voltage using digital read on a particular pin. So if the button's been pressed, we're going to get a high there, and we'll run this line of code inside our if statement. Then we need to do something. So let's toggle the value of the LED. Now there's a number of different ways we can do this. We can have a counter that stores what the previous value of the LED was and update the value of the LED that way. There's an even simpler way to do it. So we're using digital write, we're controlling our LED, which is called LED 1. Now what we want to do is we want it to be the opposite value that it previously was. We want to toggle it. So we can use the toggle command, or the exclamation mark, and perform a digital read on the same pin. And there we go. We read the value of the pin, we toggle it, and apply that as the new value of the pin. If we now upload that, okay, here we see each time we press our button, it toggles the value of our LED. We press it twice, 3 times, keeps on toggling the value of the LED. If we hold it down, it only toggles it once, it doesn't keep on toggling it.